So far we've talked about adding, subtracting, and multiplying polynomials. But there's another thing that we can do with polynomials, which is called composition of functions, where you plug one function into another function for every x that you see. We've done something sort of like this before, where we've evaluated things like f of 2. And that says to plug in a 2 for every x that you come across. Okay? We're going to do something a little bit more complicated than that now, which is evaluating something like f of g of 1. So what that means to do is to take g of 1, which we are actually going to have to evaluate first, and then plug that in for every x that we see in f. Okay, so the first thing we're going to do to evaluate f of g of 1 is evaluate g of 1. Okay, so g of 1 is plugging in 1 for every x in g. So that would be 2 times 1 plus 3, which is 5. Okay, so that's g of 1. F of g of 1 is really then the same as f of 5. I'm plugging in 5 now for every x that I come across in f. So f of g of 1 is the same as f of 5, would be f of 5, which is plugging in 5 for every x in f would be 5 plus 7. There's that 5 in for the x, which equals 12. Okay, so that's our answer there. Alright, so we can also do g of f of 1. We're going to do the same routine. First, we're going to evaluate f of 1. So f of 1 would be plugging in 1 for every x in f, so it would be 1 plus 7, which is 8. Alright, so there's f of 1. Now we want to do g of f of 1, which is the same as g of 8, because remember f of 1, we just evaluated it, was 8. Pardon my bad handwriting here. Okay, g of 8 is plugging in 8 for every x that we come across in g. 2 times 8 is 16, plus 3 is 19. So those were two examples of composition of functions where we had actual numbers that we were plugging in, f of g of 1 and g of f of 1, but we can also create a whole new function, for example, f of g of x, using our functions that we were given. So what f of g of x means is that we should be plugging in g of x for every x in f. So that's what you have to remember. We're plugging in g of x, the function, for every x in f. So f of x is x plus 7. And g of x is 2x plus 3. F of g of x is going to be taking g of x and plugging it in for x in f of x. That will give us 2x plus 3 plus 7. There's the 2x plus 3 that I plugged in for x. Then we combine it with the 7. We combine these like terms. We get 2x plus 3 plus 7. Those like terms 3 and 7 make 10. So f of g of x equals 2x plus 10. So we can also talk about the domain of this composition of two functions by looking at the input. By the input, that's what we plugged in. So the input was g of x. That's what we plugged in for every x in f. That was 2x plus 3. Okay, think about that for a second. What kind of a function is 2x plus 3? We've talked about different kinds of polynomial functions, and think back to Algebra 1 when you learned about functions like this. This is just a linear function. Now think about the domain of a linear function. There's no limit to what I can plug in for x, or you can think about the visual of what this graph would look like, and it goes on forever to the right and to the left. So the domain of the input is all reals. Now let's look at the result. The result was 2x plus 10. What kind of a function is that? What kind of a polynomial is that? That's also a linear function. Okay? So the domain on that, the domain on every linear function, is all reals. So the domain of my composition of functions is also all reals. Okay, so we've come up with what f of g of x is. That was our composition of functions that we wrote. F of g of x was where we plugged in g of x for every x in f, and we ended up with 2x plus 10. So this is just another function. All right, so if we want to, we can also evaluate f of g of 1 in this function, using this function that we wrote. That would be f of g of x plugging in 1 for every x in f. That gives us 12. Okay? Notice when we evaluated this using the composition of functions, we ended up with the same answer as what we got up here for f of g of 1 when we plugged in g of 1 and then for f. So you can do it two different ways. So now we're also going to find g of f of x. That's the composition where you're plugging in f of x for every x that you come across in g. So g of x, which was 2x plus 3, is going to get f of x plugged in for every x that you come across in g. So that would be 2 times, now plugging in for x, we're going to plug in f of x, which is x plus 7. Then continue on with writing g of x plus 3. So 2 times x, I'm distributing my 2 now, plus 14, plus 3 ends up giving us 2x plus 17. Okay, so that's my composition of functions. This is g of f of x. Okay, so we can also find the domain of g of f of x. That's the composition that we just wrote down using, just like before, the input and the result. So the input was f of x. That was x plus 7. That's just a linear function. So again, domain of the input is all reals. Okay, now let's look at the result. The result was 2x plus 17. That's a line. That's a linear function. The domain, like always on a linear function, is all reals. So that tells us that the domain of g of f of x is also all reals. The last thing I want to do is check g of f of 1. So that means take g of f of x that we just came up with, that was 2x plus 17, and we're going to plug in 1 for every x. Okay, so that'll be 2 times 1 plus 17. 2 times 1 is 2, plus 17 is 19. Notice, just like before, plugging into the composition versus plugging into just f of 1 and then plugging into g gives us the same answer. So there are two ways that you can evaluate these specifically for numbers.